Okay, so we're going to finish up these notes with how to use our graphing calculator to support us on what we just learned about the shifts of exponential functions. I first want to talk about what you should know from just looking at this function without a calculator. So first thing is whether the function is growth or decay. And the answer is growth. Remember, we know that by looking at the base. Okay, and the base is 5. So since 5 is greater than 1, it makes it growth. Is the graph reflected? The answer is yes. We know that because of the negative out front. So let's write that down. Negative out front. Okay. What are the shifts? Well, remember we said up in the exponent, shifts are a parent function, right or left, and h lies, k tells the truth, so since it's plus 2, that is left 2, and plus 8 gives me up 8. Now, at the end of the last video, we talked about that this number out here, let's change this to green, this plus 8 is your k value, and your asymptote is always y equals k. And whatever sign it is the same because k tells the truth. So I come up here for y equals 8, and I draw that invisible, think of it as an electric fence. We're going to get close to that electric fence, but we're not going to touch it. So we should know our domain. Our domain is all real numbers. And we're either going to be above or below that electric fence. And since there is a reflection, that means we're going to be below it. So y would be less than 8. So all of the things that I just did should be able to be done without a calculator, by just looking at the function. Now, how do we find the x-intercept, y-intercept, and get that final product? Well, we're going to use the calculator. So everything I'm doing in purple now is going to be things you're going to have to get from the calculator. So go ahead and go to y equals and type in the negative 5 to the x plus 2 plus 8, and go ahead and graph it. So you should be looking at what I have over here, and you see, then you notice that over here, even though you don't see the asymptote, we can tell our function is getting close, 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 close. So a few reminders of where we find things. First, the x-intercept, where it crosses the x-axis, we go to second and calculate, and we're going to calculate a 0. So second, calculate, and we're going to choose number 2, which is 0. And let's see, let's find my cursor. There he is. So arrow to the left, enter, arrow to the right, enter, enter one more time. So I have an x-intercept at 0.7, 0. And we'll go ahead and round to the nearest tenth. And that was our x-intercept, 0.70. So I'm going to put this second calc 0 up here. I wrote it in the wrong spot. No big deal. Get rid of that. Perfect. Okay, so then to find the y-intercept, we use table. And so go second and table. And remember that we're looking for when the x value is 0. So come back. So at 0, negative 17 is my y-intercept. So bummer, that's way down here. I'm not going to see it, but that's okay. I can still put it in the table. And then from here, I'm going to pick enough points to get a graph of my function. And if you notice when you look at the table, there's a couple that stand out to me. -2, 7, -1, 3. I'm going to use those. Okay. And that's fine. I also have my x-intercept here at 0.7. Looks like it should be at -0.7. I think I forgot the negative. Okay. And so then I'm going to graph, connect the dots, looks like this, come up here, and notice that I didn't cross my asymptote, and I have that nice exponential growth. I start close to the asymptote and then go down in the negative direction. Okay? So what I would like you to do now is pause the video and try everything below, doing the same thing. Okay? And I want you to do everything we did in red and green non-calculator, and then use the calculator to support those right there. So go ahead and hit pause and try on your own for number 2. Okay, so things that you should have gone ahead and done. Non-calculator, we start by, is this growth or decay? It is decay because the base is less than 1. Is the graph reflected? The answer is no. There is no negative out front. The shifts are right 1 and down 4. That down 4 means that my asymptote is at y equals -4. So I'm going to go ahead and put that on there. My domain is always all real numbers. Since there's no reflection this time, my range will be y is greater than -4. Remember, the range is always based off of that horizontal asymptote. Okay, well, from there I need to go to the calculator and get a little bit more information. So I'm going to change to purple so you know that this is all calculator stuff on here. So I'm going to put my function in y equals 1/2 the x minus 1 minus 4. Take a look at the graph. Okay, I'm going to start with finding my x-intercept. So second, calculate, and I'm going to choose 0. I'm going to come up here, arrow to the left, hit enter, move down, hit enter, enter one more time. It looks like I have an x-intercept that's nice and clean at -1, 0. To find my y-intercept, I'm going to go to the table, so second table. Arrow down just a little bit. Okay, it looks like I have a y-intercept at 0, -2. And from there, maybe grab a couple more points off the table to help me finish my graph. Looks like -2, 4 would be a good option. I have a good option at 1, -3, and that's probably enough to get going. Go ahead and connect the dots. Hopefully yours looks a little nicer than mine. And there we go. So again, making sure you understand all the non-calculator type of questions I could ask. That final product of getting it on the graph, we're going to use that calculator. Thanks so much for watching the video. You're ready for your homework now, and I'll see you guys tomorrow.